this is a type of problem where you need to square, or it's easier to square because you want in the end to have one common function, which makes it easier to solve the trigonometric equation. So now I'm going to square both sides. Okay. So now you want to FOIL cosine x plus 1, and when you FOIL it, you get this. So this is what I got when I FOILed cosine x plus 1, which becomes cosine squared x plus 2 cosine x plus 1 equals sine x squared. And we know that this is a Pythagorean identity, which the Pythagorean identity is 1 minus cosine squared x. And then we're just going to write this over again. So now we want to subtract the 1. And then when we rewrite that, we get cosine squared x plus 2 cosine x equals just negative cosine squared x. And now what we can do is add the cosine squared x to this cosine squared x because they are the same variable or common variables. Add. Okay, so then you would get, so now that we set this equal to 0, we can factor out a 2 cosine. So we're going to factor out a 2 cosine x, and then we get cosine x plus 1 equals 0. Now we want to set this one equal to 0 and this one equal to 0. Now that we set them equal to 0, we're going to divide 2 here. We get cosine x equals 0, which on the unit circle, cosine equals 0 at pi divided by 2 and 3 pi divided by 2. And for this one we subtract 1. We get cosine x equals negative 1. And cosine x equals negative 1 at pi. At pi. Okay, now we're going to check for extraneous solutions. So we had the answers pi divided by 2, 3 pi divided by 2, and pi. Now the way we can check for extraneous solutions is by plugging the solutions back into the original functions. Let me write the original function again. So this was the original function, and now we're just going to plug it back in. So we're going to check the first one. It's going to be cosine of pi divided by 2 plus 1 equals sine of pi divided by 2. So cosine of pi divided by 2 is 0. Then we add 1, which gives us 1. And sine of pi divided by 2 is 1. So because they equal each other, we know that this is a solution. So that's good. So let's check the next one. So cosine of 3 pi divided by 2 is 0. And then we add 1 and we get 1. Then sine of 3 pi divided by 2 is negative 1. And we see that these don't equal each other. So this is our extraneous solution. So we count this one out. Okay, so this is our last one we're checking for, and cosine of pi is negative 1. We add 1 and we get 0. And sine of pi is 0. And we get these are equal to each other, so this is a solution that works also. So we found out that 3 pi divided by 2 is an extraneous solution. So now that we found that our answers are now only pi divided by 2 and pi, because we found that 3 pi divided by 2 was an extraneous solution, we see that this problem also does not have the restrictions, so we always have to add plus 2 pi k, where k is an integer. And that concludes this problem.
So I'm going to show you how to do a problem where you have to let p equal a squared trig function. So for this problem we have a restriction, and that is that our answer has to be between 0 and 2 pi. And our problem is secant to the 4th x minus 3 secant squared x minus 4 is equal to 0. So in this problem we can let p equal secant squared x, and we can rewrite our original problem as p squared minus 3p minus 4 is equal to 0. So this equation can be factored into p plus 1 times p minus 4 is equal to 0. And now you can rewrite this equation using p equals secant squared x into secant squared x plus 1 times secant squared x minus 4 is equal to 0. So you have secant squared x equals -1, and you have secant squared x minus 4 is equal to 0. Actually, we were going to make that secant squared x is equal to 4. So if you take the square root of both sides, you get secant of x is equal to radical -1, and there you get an imaginary answer. So that portion is going to have no solution because you can't take the square root of nothing. And then over here, when we take the square root, we get secant of x is equal to plus or minus 2. And we can rewrite secant x as 1 over cosine of x is equal to plus or minus 2. So when you cross multiply, you get 1 is equal to plus or minus 2 cosine x. So you can divide this into plus or minus 1/2 is equal to cosine x. So you're looking for angles that have a cosine of positive or negative 1/2, and those are all of the pi over 3 angles. So because it's plus or minus, you can get all of the answers from all of the quadrants, not just certain quadrants. So your answers are pi divided by 3, pi, 2 pi divided by 3, 4 pi divided by 3, and 5 pi divided by 3. So that is how you do a problem when you have to let p equal a squared root function.
So there are other types of problems that we didn't cover in this video, and they, for the most part, involve all the same skills that we've been covering, and some involve different skills, but it's definitely something that can be picked up. And all these problems are included on the worksheet, so do the worksheet. These problems involve a different type of problem is known as rewriting with a single trigonometric function. So you'll have two or more different functions, and you have to change it to one function. Another problem that is seen is using a calculator, and you'll have to find. Usually it involves two different lines, and you could see where they intersect, and that will be part of the answer. And that's it.
Thanks for watching our video, and we hope that you learned about solving trigonometric equations. Good luck on your final.